Okay, so let's start with the explanation part. The project is all about leveraging transaction patterns and loan data for enhanced fraud detection. So we have used two data sets here, Lending Club and Play dataset. And the research question is to see if the credit behavior features predict loan defaulters better, or the demographics and employment informations are predicting it better. The second one is we have to see where are people allocating the spending patterns, that is, are they spending more on luxury, are they spending more on essentials, etc., and what is more causing more defaults. Okay, and then the third one is, does incorporating real time spending patterns, if we add that to the default prediction models, will it improve the accuracy any better? So we have used some literature reviews and they were really helpful because I was able to identify all these variables that are important to the analysis in financial data sets. Now, let me just come here. This is the ETL pipeline. This is the mains Python file that I have written to automate. Now I'll just delete the file, the data set, and let me also delete the output because I'd already run that. And let's start with the main file. Let me put the pipeline to run so that it will run by the time I explain things. Okay. So now we have two data sets. One is CSV and one is JSON. Okay, so the Lending Club data set was taken from, one second, why is this? Okay. Just a second. Okay, so the Lending Club dataset was taken from Kaggle and the Plate dataset was taken from API from the Plate. And here we had to create different sandbox accounts. So one sandbox account was able to fetch only 500 transactions. So I had to create 100 different synthetic sandbox accounts so that I could get at least 5,000 data rows from the uh, Plate dataset. So here we have used the dataset from last 30 days, and we have used access keys and liabilities, get requests, etc., and then we had to exchange all of these requests to get more and more data sets. So we took more some data sets from purpose, for why, where are they spending, and then some transactions of which mode are they using, etc. And by doing that we were able to I was able to take 5,000 transactions, and the data set was stored into a JSON file. Now I had to store all of these data sets somewhere. So I have taken Amazon S3 bucket as a storage, as a central storage. And in the S3 bucket, if we go, we have a bucket created over here. And we have put both these data sets in this bucket. Now to process these data sets, I have brought them to um, VS Studio and used PySpark in it because PySpark is good for large data processing. Now, in the main file, if we see, okay, the fetching of S3 is already done. So we got the data set here. We can see that the Lending Club and Play data sets are already fetched automatically from the Amazon S3 to Spark. After that, the second thing is Lending Club transformation. So here also we have automated the entire process. We have created different functions and it will run automatically. So the first one is missing value treatment. The variables that were having more than 50% of missing values were deleted from the data set. Then we have created the target variable. The charged off and defaulters will be default and the others will be non-defaulters. We have selected particular columns and deleted some columns on the basis of literature review and domain knowledge, like installment can be calculated using loan term and interest rate. So installment is actually not needed, we can remove that. So on the basis of that we have done the analysis. And then we have also done outlier treatment. So for example, debt to income ratio, it is a ratio, so the value has to be between 0 and 1, but there were 0 and 100, but there were some instances where the values were more than that, so we have deleted, so we have capped it to 75%, and then we have done some imputation, etc. All of that is done, and then the lending club, so it is still running, it will give us the output later. In meanwhile, let's see the plate transformation. In plate transformation, we're taking the JSON file and selecting few columns that were important, and then again creating few categories, etc., doing the missing value treatments, all of that same thing, and then storing it. So now we are storing both the JSON file into CSV because we have to upload it to a same database. And the lending club, since the CSV is taking a lot of space, I've converted into a pirate version of it, sorry, the Parquet version of it, and so it takes very less space. Now both of these data sets are ready, but we have to put it into a database now. So for that we go to RDS, and here we create a database known as Loan Project DB, and we create it using PostgreSQL. Now here we also have created the inbound. Now to get the PostgreSQL over here, we have brought it in the, we have downloaded the PostgreSQL in local. Now let me just check if it is run. uh, Okay, it might take some time. Actually, the lending transformation is still going on. But if we run this code over here, once the ETL pipeline is completed, it will give us the data sets. It will create first a schema, then a table, and then it will store both the data sets into the table. And then we can access the data sets from here. I will show you once the pipeline has run. I think it has run for lending club. Now it will run for plate, and then it will run for the PostgreSQL connection. Once the dataset is ready in the database, I have connected it to Google Colab because Colab is good for visualization and model building purposes. So I've connected using the install these libraries and connected using the host and the port and the database name, etc., written the query for connection, and we have the datasets here. So for lending club and plate we have both. Then let's go to the here. If we see the first question in the analysis that we have, that is, can credit behavior predict loan defaulters more effectively than demographics? So we can see that grade now, as the grades are increasing, the defaulters are increasing a lot. Like if a person is having grade G, then their defaulters are very high. If a person has taken loan for 60 months and is having a very high interest rate, more than 15, 16, 17, then the default rate is also high. So we see some uh, and then there are more that I have done more EDA just to understand what data set has to tell. And then we've encoded, and using SMOT we have balanced the data, etc. Using logistic regression, we've done forward feature forward sorry, forward feature selection, and then we come to know that interest rate, grade, FICO range, these are very important variables in the data. We also see that precision has dropped drastically, but recall is quite good. And precision has dropped maybe because we have used SMOT for training, and then for testing it has dropped because of that. But we come to know that the credit worthy information is more important to understand the default rate. The second one is, where are people spending? So we actually come to know that the people are spending more on luxury than on um, essential things. If we see the month on month analysis also, the spend for essential is stagnant, but the spend for luxury has increased. Now it has dropped in April because the data set was very less for April, and for the previous months it was we got it for 30 days. For April the 30 days were not completed, so that is why it is very less. Now the third question is, does incorporating the real time spending patterns into the default prediction will it improve the model's accuracy? So now there was no common user IDs to merge lending club and played data set. But what I've done is I've taken 10,000 stratified samples from lending club, and I have seen the pattern of the customers. Like I've seen, observed their behavior, and on the basis of the behavior, I have mapped the category group and the payment channel into the lending clubs data. And by that we see that if we see in the category group, we see that transportation and luxury are having very high default rates. Surprisingly, online payment is having lower default rate as compared to in store. And if we use these variables and build a model, again we come to know that precision has improved a lot, recall has improved a lot, the model is more standard, and overall the predictive performance has increased. So in this project we saw that the important variables are interest rate, grade, fico score, etc. And people are spending more on luxury, and also the defaulters are those who are spending more on luxury. And then if we add the spending patterns into the data set, it will give us better results for identifying the frauds. For future, now we, since we have used synthetic plate dataset, but we can use live plate dataset, that would give us more strong results. And also we can automate, now we have automated the pipeline using python code, but we can use amazon lambda for doing that. Now the pipeline is successfully completed, we can see that. Also if you want to see the code here, we have this also running. So here are both the data sets in the, and if you want to see the data set, it is here. So all the connection is done automatically and it is connected. Thank you.